In your last lesson, you learned what a quadratic equation is, and you learned how to solve quadratic equations that do not have a linear term. Well, as you can see in today's lesson, we're going to solve quadratic equations that do have a linear term. This quadratic equation does have a 12x in the middle here. We need to solve for x. Now, don't write this down, just kind of watch this for right now. What would happen if I tried to solve this quadratic equation using the technique I learned in the last lesson? Let's suppose I would try to subtract the 27 over to the right-hand side. And you know what? While I'm at it, go ahead and subtract the 12x from the right-hand side as well. I can get this x squared all by itself on the left-hand side, but I would have a negative 12x and a negative 27 on the right. And if I tried to use my square root method that worked in my last lesson, x equals, well, I'm left with kind of this mess. See, this linear term, this 12x, really gets in the way, and there's just no simple way to solve this. I can't just plug this in my calculator to get the answer. This 12x is going to make things kind of messy. It's going to make our lives way more difficult, but I hope you're up for the challenge because this is what we're going to tackle in today's lesson. All right, so in today's lesson, we're going to learn how to solve quadratic equations, QEs, by factoring. And ultimately, our first example here is going to be that exact same equation. I'm going to show you a method on how you can solve an equation, quadratic equation, even if it has the linear term, like the 12x. Before we can do any of this, though, we really need to review what's called the FOIL method. Okay? Let's do this one together, and I'm going to have you try this one on your own. Here's what the FOIL method is. You learned the FOIL method, I'm sure, in Algebra 1. Anytime you have a binomial like x plus 8 times another binomial like x plus 2, there's actually 4 multiplications that need to happen. First, you need to distribute this x. We're going to do x times x is x squared, and x times 2 is 2x. But then we also need to distribute this 8. We need to do 8 times x, which is 8x, and 8 times 2, which is 16. So I've done these 4 multiplications, and now generally what happens with binomials like this, generally we can combine these inside terms together. 2x plus 8x is 10x. And voila, we have simplified these binomials by foiling. Go ahead and hit pause right now. Give this one a try. Let's see what you come up with. Hit pause. And I've got this answer covered up, but hopefully the answer you got was x squared minus 2x minus 48. Now, you know what? Let's look for some patterns here. When we have these simple binomials like this being multiplied together, look at this pattern. Here I have an 8 and a 2. Well, did you realize that if you take 8 plus 2, you get 10? And my middle term in the final answer equals 10? And did you realize that if you do 8 times 2, that equals 16? And my constant term at the end here equals 16? Now, is that just a coincidence? Or do you think we've found some type of pattern here? Let's look down here. Let's look down at the next example. You know, if you take 6 plus negative 8, you get negative 2. Well, look, that's the linear term I get in my final answer. That's from combining the negative 8x plus the 6x. You get negative 2. But did you know that if you do 6 times negative 8, you get negative 48, which is my constant term? That comes from the last step, taking 6 times negative 8. This pattern actually holds up in any of these simple FOIL method problems where you just have an x here and an x here. This little pattern holds up. So I'm going to introduce you now to this concept called reverse FOIL. See, in reverse FOIL, we want to do the exact opposite thing here that we did over here. Here we're starting with this, it's called a trinomial, this quadratic trinomial, and we want to break it down into 2 separate binomials. And we're going to use this little game, almost this little puzzle. We're going to say, let's find 2 numbers that add up to the linear coefficient of 12. And then we're also going to find 2 numbers that multiply to the constant term, the 27. Now I don't have any like great technique on how to do this. What I'll do a lot of times is I'll try to think in my mind, hey, what numbers multiply to 27? And I know 27 times 1 does, but the only other one that really jumps out at me is 9 and 3. I know 9 times 3 equals 27. Let's see if it also fits this first condition here. Does 9 plus 3 equal 12? Well, yes, it does. And so with this in mind, me being able to kind of solve this little puzzle here, I have found a way to reverse FOIL this trinomial. I can now write this x squared plus 12x plus 27 as, what you do is you take your x squared, you break it into an x here and an x here. This 12x is going to be generated, I'm going to put a plus 9 and a plus 3 because I know that 9x plus 3x will give me the 12x. And then this 27 is going to be generated. I know when I do 9 times 3, I'm going to get 27. This quadratic trinomial here, x squared plus 12x plus 27, can be broken or factored into x plus 9 times x plus 3. And it's because 9 plus 3 equals 12, and 9 times 3 equals 27. So let's try one more here. In this case, I would need two numbers that add up to 2 and multiply to negative 15. Stop and think about this one for a little bit. As a matter of fact, go ahead and hit pause. See if you can kind of solve this little puzzle here. Hit pause, see if you can find the answers. And here you go. Those two numbers are 5 and negative 3. See, the only really good way you can get 15 through multiplication is either 15 and 1 or 5 times 3. And now it needs to be a negative 15, so one of these numbers actually needs to be negative. Now, I did positive 5 and negative 3 because that does multiply to negative 15, but then when you add a positive 5 and a negative 3, that comes out to positive 2. Now, the way you write your factored answer then, this would become x plus 5 and x minus 3. This is how you reverse FOIL this original x squared plus 2x minus 15. Try this last one completely on your own. I'll help you set it up. We need two numbers that add up, this time to negative 10, and multiply to positive 16. Go ahead and try this one on your own. Hit pause now. All right, and here is your answer. The missing numbers would have to be negative 8 and negative 2. See here, I needed two numbers that multiplied to 16, and I knew I was either going to use 4 times 4 or 8 times 2 or 16 times 1. But I knew they also had to add up to negative 10. So I knew here I had to use two negatives. A negative times a negative will give me the positive that I want, but then a negative plus a negative will give me the negative that I want. So here it is factored, x minus 8 times x minus 2. And I'm going to add these little, you might want to add this little thing to your notes here to help you remember. If you have a case where it has to add to a positive and multiply to a positive, if this number and this number are positives, then your two numbers are always going to be two positives. Okay. Now, in the case where it has to multiply to a negative, anytime your two numbers have to multiply to a negative, you're going to use one of each. You're going to use one positive number and one negative number. And then in the last case, if it ever has to multiply to a positive but add to a negative, in these cases you will always use two negatives. All right, so let's put this to use then. Example number 1, here we have an actual equation. X squared plus 12x plus 27 is equal to 0. We need to solve this. Well, as I demonstrated at the very beginning of the lesson, there's no great way to isolate this x squared, to get this equation in x squared form where you can solve it by square rooting both sides. That's just not going to happen. So in cases like this, a quadratic equation that does have a linear term, you actually want to leave it in standard form here. That means setting it equal to 0. And then we're going to use the trick that we just learned. What two numbers add up to 12 and multiply to 27? Now you'll notice that this is a repeat. This is one we had already done earlier. So the numbers are 9 and 3, meaning the left-hand side of this equation can be broken into its factors of x plus 9 times x plus 3. Now this is an equation this time, so we also write that that's equal to 0. Now what we have found here, these are called the factors of the equation. The factors of this equation are x plus 9 and x plus 3. We found that by finding this 9 and this 3. These are called the factors of the equation. Now, the way you can find the solutions to this equation, what we're going to do now is we're going to take each factor and set it equal to 0. We're going to say, hey, what would happen if x plus 9 was equal to 0? And we're also going to say, hey, what would happen if x plus 3 were equal to 0? Now, each of these equations are really easy to solve. Here, we would just subtract 9 from both sides, and we're left with x equals negative 9, and that is my first solution. Over here, I subtract 3 from both sides. I'm left with x equals negative 3, and that is my second solution. And it's important to notice this distinction here. If my factors are x plus 9 and x plus 3, then my solutions are going to be the opposite of that. My solutions are x equals negative 9 and x equals negative 3. Solutions are always going to be the opposite of your factors. That's an important distinction to make. And I can go into the why this happens. Think about it for a second. And let me get a calculator real quick. Think about it for a second. If you plug negative 9 in as a solution in for x and do negative 9 plus 9, that would give you 0. And then negative 9 plus 3 would give you negative 6. But if you plug negative 9 into this, you would get 0 times negative 6. Well, 0 times anything, which that should be a 0 there. Right, a 0. 0 times anything is just 0. So of course, if you plug a negative 9 into this factor and do negative 9 plus 9 is 0, it doesn't matter what you multiply it by, that's always going to equal 0. And so that's why negative 9 would always solve this particular equation. But the same is true of negative 3. If you plug negative 3 into this factor and do negative 3 plus 9 is positive 6, but then negative 3 plus 3 is 0, well, 6 times 0, of course that's going to equal 0. Anything times 0 is equal to 0. And so that's why these solutions, that's why using these numbers that are the opposites of the factors will always give you an answer of 0. And if you want to prove it from the very beginning, I can prove it to you real quick. If you do negative 9 squared plus 12 times negative 9 plus 27, yeah, it works. That's equal to 0. But that's not the only answer. The same would also be true with your negative 3. Negative 3 squared plus 12 times negative 3 plus 27. Yeah, that's going to equal 0 as well. These are the only two numbers in the world that would make this equation come out to equal 0. We can find it by factoring. All right, and I know this is one of the lengthier videos, but so let's end this with by doing some questions right off the homework. And I'm going to skip to question 6. So here's our equation, x squared minus 6x plus 9 equals 0. The next thing it wants us to find is the factors. Well, here's where I got to do this trick. I got to find two numbers that add up to negative 6 and multiply to positive 9. Well, remember the rules. If it multiplies to a positive but it adds to a negative, we're going to use two negatives. And I know this either has to be 1 and 9 or 3 and 3. Well, if you think about it, the 3's are going to work perfect. Negative 3 plus negative 3 is negative 6. Negative 3 times negative 3 is positive 9. So my factors, x minus 3, x minus 3. These are called the factors of the equation. X minus 3 and x minus 3. Okay, so that's what we'd put here for the factors. And then remember the solutions then are just the opposites of this. I'm going to show the work, although you really don't even have to show the work. If we set x minus 3 equal to 0, that means we'd have to add 3 to both sides, and x is just going to be the opposite of that. X is going to be positive 3, And then over here, if I set x minus 3 equal to 0, I would just have to add 3 to both sides. And x is over here, x is also equal to positive 3. So here for my solutions, I'm going to put positive 3 here. And kind of a coincidence here, they both came out the exact same. I'm also going to put a positive 3 here. That does not always happen, but in this case, my two answers were exactly the same. If this ever happens, this is actually called, FYI, it's called a double root, or you can also call it a double solution. That just means you get the same answer twice. Now technically, you're still supposed to write it down 2 times, even though it's just a repeat number. You get the answers are 3 or 3. Take your pick. So that's question 6. Now in questions 9 and 10, I was kind of mean to you. Here I gave you a quadratic equation that's not in standard form. And I did that on purpose because I want you to realize this whole idea of factoring, it only works if the equation is equal to 0. So here, if the equation is equal to like -3, not going to work. You can't use factoring on it. But you know, with one quick move, we can make this equation equal to 0. I'm going to add a 3 to both sides of the equation. And x squared minus 5x. -9 plus 3 is -6. And then -3 plus 3, those cancel out. You can leave a 0 in its place. So here with one quick step, we're going to add this 3 over to the left. We've taken an equation that's not in standard form, that was not equal to 0, and we made it equal to 0. So we need to get to, on questions 9 and 10, we need to get to this step first. So now we need to find two numbers that add up to -5 and that multiply to -6. Now remember, anytime your numbers need to multiply to a negative, I'm going to use a positive and a negative. So oh, this one's a little tricky. It's either going to be 1 and 6 or 3 and 2. And a lot of times you'd be tempted to say, oh, it's going to be the 3 and the 2. It's going to be the 3 and the 2. It's got to add up to 5. But the negative sign actually kind of twists things around a little bit. The answer to this one is going to be -6 times a 1. -6 times 1 gives us our -6. But then -6 plus +1 gives us the -5. There's actually no way to do this with the 3 and the 2. You have to use a -6 and a +1. Now remember, these are called my factors. So my factors would be x minus 6 and x plus 1. These are called the factors. So, oh, here you didn't even need to write the factors here. Usually I made you write down the factors. Here you do not have to, but know that these are called the factors. So then my solutions are just the opposites of that. If you set x minus 6 equal to 0, well, the solution comes out to +6. And if you set x plus 1 equal to 0, well, then the solution comes out to -1. So for my solutions, make sure, even though my factors were a -6 and a +1, those are my factors, my solutions are the opposites of that. My solutions are 6 and -1. And I've set up Canvas where it doesn't matter what order you put that in. I did the 6 first and the -1 last. You could flip the order. I've set up Canvas. It would give you credit either way. Question 10, I'm not going to do the whole thing, but here's how you would start. Subtract your 6 from both sides. You'd be left with k squared minus 2k minus 35 is equal to 0. And you would set that up from here. Now, I'll give you a hint. We're gonna be using a 7 and a 5 in one regard, but one's gonna have to be positive, one's gonna have to be negative. You can figure it out from there. All right. Hey, best of luck on this assignment. Take care. Bye.